Let's solve some very basic structural analysis problem. For problem A, it is a beam with fixed end A under two external forces acting in different positions of this beam. One is in the middle at an angle of inclination of 60 degrees pointing downward. Another force is acting on the tip. It is pointing upward with an angle of inclination of 30 degrees. Their magnitudes are 50 kilonewtons and 20 kilonewtons respectively. You are required to find the reaction force and the reaction moment at this fixed end. Besides, a beam with fixed end A and the roller support C is subject to a loading in the middle as shown here. If AB equals to BC equals to 1 meter, you are required to find the reactions at A and C. For the first problem, first sketch the orthogonal components of forces as well as the moment at this fixed end. By our equations in statics, we know that the net force in x direction is 0, meaning that AX plus PB cosine 60 degrees minus PC cosine 30 degrees equals to 0. Also, the net force in y direction is 0, meaning that AY minus PB sine 60 degrees plus PC sine 30 degrees equals to 0. Apart from that, we also consider about the moment, about point A, but we know that when PB is decomposed into orthogonal components like this, then the horizontal component will provide no moment to this fixed end. The vertical component will provide the moment with the arm AB. Similarly, for PC, if we decompose it into orthogonal components, it will have horizontal and the vertical one. Similarly, the horizontal one does not provide any moment, but the vertical one will provide moment with the moment arm AC. Therefore, we can write MA plus PC sine 30 degrees AC minus PB sine 60 degrees AB equals to 0. This system should be easy for you to solve. The answer is shown here. You can verify it yourself later if you have time. For part B, it has a 50 kilonewton force acting in the middle at an angle of inclination of 60 degrees. Similarly, we draw the orthogonal components at the pin A, as well as the vertical support force Cy at point C. Solving for the net force in x direction, net force in y direction, and moment about point B. Actually, you can take moment at any point you like on this beam, but taking the moment at point B is just for ease of calculations. Consequently, solving this system, you will have those answers. It is left to you for checking.